again, you can see the freaking shadow of my phone. I'm holding my phone because I'm not at work, so I can't set it down. But I am just going to make sure we've just hopefully finished a week of practicing multiplying polynomials, specifically binomials for quadratics. So I just wanted to review, if you did page 698, what you should have done. I'm hoping you guys have done this to death. I'm hoping you've done this so many times that it feels like clockwork and it's perfect for you. So I just am going to do like C, for example. I'm on page 698, which this is supposed to be a discovery about the patterns that happen when you have the same sort of numbers in your polynomials with just switched signs. So just to show you the box method again, of course, if you would like to just do it in your head, eventually you can, but of course we suggest using this box method. This is not going to look good in marker. So if we have 3x minus 1 and 3x plus 1 as our two binomials, we're going to multiply these times both and this times both, so we can use columns and rows to make that happen. So 3x, we are going to have to multiply. And then separately, negative 1, we're going to have to multiply. And then 3x, and then positive 1 is what we're multiplying by. So I'm not going to leave the plus sign with the 1 because that's just a positive 1. And if this is, like I said, if this is something you've done a million times by now, you can skip this portion of the video. But when you put these here, you're going to multiply these two things together. So 3x times 3x, 3 times 3 is 9. I'm sorry, this is not focusing very well. And then x times x is x squared. Doesn't look great. 3x times 1 is 3x. 3x times negative 1 is negative 3x. And then 1 times negative 1 is negative 1. So all of this is our solution. So we have a 9x squared term, a positive 3x term, a negative 3x term, and a negative 1 term. And if I combine these two together, I find out that they cancel. And so we always end up combining the two terms in the center together, the x terms, and in this case, they cancel out completely. So we just get 9x squared minus 1. This doesn't look super quadratic. We have an a value of 9. We have a c value, whoa, a looks like 9. We have a c value of negative 1, but our b value is 0 in standard form. So this will end up happening anytime you have a positive and a negative. They will always have something that cancels out, but that's not the case if they're both positive or both negative. And so if I wanted to do the second one for you, 2x plus 1 times 2x plus 1, oh my lord, 2x plus 1 times 2x plus 1. 2 times 2 is 4x squared, 2x and 2x, and 1 times 1 is 1. So when you write out the solution, you get 4x squared plus 2x plus 1. And in this case, these do not cancel. They come together to make 4x because 2x plus 2x is 4x, and then I bring down the plus 1. So here's our new polynomial. It's a trinomial. It's a quadratic with an a value, a b value, and a c value. So hoping all of this is good, I am going to work next week. I am going to hopefully show you this today that will help you with the worksheet that you got, because you are going to be going backwards. So here are some examples. First of all, I would encourage you to pause the video and do these on your own so that oh my God, I'm so sorry. Holding my phone is not easy. So that we just make sure that you're clear on how to do this. It doesn't matter where we put the x minus 3. You can put it on the side or on the top, you know, just pick one for each. So I've got x and a negative 3, and then I have a 2x and a 2, and the box helps me multiply this times both and this times both. 2x times x is 2x squared, 2 times x is 2x, and 2x times negative 3, 3 times 2 is 6, so it's negative 6x, and then 2 times negative 3 is negative 6. So when you write all of these out, feel free to combine like terms before you write them down. We always are going to have these two that combine. So my 2x squared is by itself. Negative 6x and 2x will combine to make negative 4x, and then negative 6 is our constant term. So now we have a equals 2, b equals negative 4, c equals negative 6. Very fun. Our y-intercept, remember all those things we've learned. Our roots are, you know, sort of here and here. And then here's a practice if you'd like to do when there's 3 terms. So let's say we're multiplying x and y and negative 6, and this one is x and negative y. You won't be doing a lot of this, but using these multiplication boxes is a way to multiply any polynomial. X times x is x squared, x and times y is xy, it's just x times y. X times negative y is negative xy. Negative 6 times x is negative 6x. Y times negative y is negative y squared. I'm hoping you pause this and do this by yourself. Negative 6 and negative y is positive 6y. So part of your learning intention is also combining like terms, and we call that adding and subtracting polynomials. So when I write out the answer, I see that I have some like terms here. Let's see if you guys can identify what are like terms. So x squared is the only one. xy, there's one right here. So these are like terms. Negative 6x, it's the only x term. 6y, it's the only y term. And y squared, it's the only y squared term. So because we define like terms by their variables, these are the only ones that are going to combine. And you might notice one is positive and one is negative. And because xy is like a group, it's like its own thing, these cancel. So those will end up canceling. So if I write my final answer, I've got x squared, negative y squared, I have negative 6x, and I have positive 6y. And that is my final answer, a polynomial with 4 terms. Just so you know for future, we do always go in alphabetical order. Highest powers go first. So x, y squareds, and then x, y, no squareds. Okay, here is where the magic happens. It's 8 minutes into this video. I'll just do some timestamps. 8 minutes into this video, we see that instead of giving us the things to multiply, they've given us the answer. So this is when you get to go backwards. Going backwards is called factoring. So we're going to try to figure out what 2 factors we would have started with to get this as our answer. So if you're proficient in doing all of your multiplication, you will recognize that this x squared number always comes from this box. So you'll always take this whole term and put it in this box. You might recognize that the last term, the c value, always comes from the bottom right box. So I'm going to take my negative 8 and I'm going to put it down here. Now the 7x is the harder one because it's usually combined from these two. So I don't actually know what's going to combine here. This is all of the information I have, and the rest of it is kind of a puzzle. There's a way to do it without a puzzle, but this is probably better for you guys to start with. So based on all of the learning you've done so far, you're asking yourself, what goes here and here to multiply to make these? So I like to start with x squared because there's only one thing that I could put here and here. It has to be a single x times a single x because x times x makes x squared. There are no coefficients. It's just 1x times 1x is 1x squared. Now the next part is more difficult. We have a clue that our negative 8 goes down here. And so we need to think of 2 numbers that multiply to negative 8. And there might be some guessing and checking that happens at this stage if you're not using the other method. But let's see, what are some factors? This could be a 2 times a 4. This could be, let's see, what else is a factor of 8? 8 times 1. So we're gonna see, like, if I put a 2 and a 4 here, would this make 7x? So I'm gonna ask you to imagine this guess and check. Like if that was a 2, I would have 2 times x, and if that was a 4, I'd be 4 times x, and those would combine to make like a 6x, not a 7x. So I know that this one is more confusing, but I'm just going to give you the answers. The answer is, if we combine an 8 and a 1, one of them has to be negative. And to make positive 7x, our 1 being negative would make that work. So I'm going to say, I always like to come up with the 2 numbers first. This is going to be an 8 times a 1, which would give me an 8x and a positive 1x. But one of these has to be negative to make this 8 negative, and 8x and 1x combine to make 9. So I need to subtract this. Subtract, subtract. So if I multiply now 8 times negative 1, that is going to be a negative 8, and 8x and negative 1x will get me a 7x. So all of this thinking isn't easy. Typically, I would have you guys do this on whiteboards. There's a lot of, like, you know, guessing and checking maybe, but that's it. Now that we have everything on the inside, and I guess I should have written this in purple because these are our answers, negative 1x. We have our answer. Our original polynomials to get us this solution out is an x and an 8, positive 8, as one of our factors. And then the second factor is x minus 1. And so we're trying to figure out what went on the sides to get to the inside. So this one is actually significantly easier. I want to see, if you had just done this one, what are the first steps to this? Do you know the first steps? So your first step should be, I know that this goes in the top box. The 30 is our constant term. It's going to go in the bottom box. And I don't know what's going to combine to make 13, but I can start figuring out my logic puzzle here. If this is x squared, I know that it has to just be an x times an x. Easy. And now I think, okay, there's 2 constant numbers that multiply to make 30. Let's think of some things that multiply to make 30. We've got 6 and 5. We've got 10 and 3. We've got 30 times 1. You know, and that seems pretty good to me. And now we're going to figure out what times what would give me 30, that if I also combined the x terms, we'd get 13. So we're looking for 2 numbers that multiply to 30 and add to 13. These multiply to 30 and add to 13. So that means those are my magic numbers. If I made this a 10 and this a 3, these would multiply to be 30, and then a 10 times an x would be 10x, and x times 3 would be 3x, and holy crapola, hope I don't get demonetized for that. Oh my god, I couldn't even finish the joke before I finished it. So lame, I'm sorry. These 2 would add together to make 13x. So we've finished our puzzle. We've found the solution. The solution is that we should have started with x plus 10 as one factor, x plus 3 as the other factor. Finally, we've got this little guy down here for you to do on your own. Hopefully you finish this on your own. You know that you're going to put the 6 down here, 2 numbers that multiply to be 6, and 2 numbers that multiply to be x squared. Take a second to try that. Oh my god, I'm giving you the answer. Don't look. Don't look, no spoilers. And if you've paused and finished it, voila, this is the answer. So this is called factoring, where we take this A, B, and C standard form and we turn it into the 2 factors that multiply. And guess what, folks? R1 is negative 3 and R2 is negative 2. Remember that? So now we've got 2 forms of a parabola, if you consider these quadratic, with a y-intercept at 6. Oh my god, I'm so excited. I just have to do this. I have to. My y-intercept is up at 6, And my roots are at -2 and -3. Let's see, -2 and wait a minute. Did I just ruin my life? This doesn't make sense. How do I have a parabola that crosses through here? But oh, I'm sorry, I'm an idiot. I'm sorry. Ugh, it's a happy parabola. So because it's a happy parabola, we know it's gonna go down like this somehow. I wish I could cut that piece where I just freaked myself out. And we don't know the vertex until we put it into vertex form, but surprise, that is your next learning intention. You are gonna also learn how to turn this into vertex form to find the vertex. It's so exciting. I love this 15-minute video. I love you. I hope that you do okay on Mathia. These things with combining like terms is what Mathia is gonna be. So hopefully you're able to like do a little bit of practice for that, but it's not as important. You just have to get through that in Mathia. Okay, adios.